question we got moment of inertia as 67 plus k square times ma square, right? Now we are moving to the second part. In the second part it says that this is rotating about the axis L, which is passing through the point A. That is mentioned here in this particular paragraph. It is mentioned where the axis L is. So axis L is here, which is passing through A, perpendicular to the plane of this entire system. And it is performing small oscillations of period 4 pi root A by G. So this is the time period 4 pi root A by G. Now, what we are going to do is, we are going to take a new equation connecting moment of inertia and d square theta by dt square. So the product of this is equal to negative of, this negative shows the forces, opposing forces of this mass which is acting downwards. This is of mass 3m. Then the mass of the rod 2m is acting downwards. Mass of the particle m is also acting downwards, right? All these are the opposing forces, and in order to denote these opposing forces we put a negative sign. So negative summation of each mass multiplied by its distance from the axis of rotation. So I can write d. Okay. And this is multiplied with g sine theta. This is the formula. Okay. I d square theta by dt square is equal to negative summation of mass times distance times this is the part which comes under the summation, which is multiplied with g sine theta. So I can write I d square theta by dt square is equal to minus, I'm going to start considering from here. So 3m, mass of 3m is at a distance of 4a plus a, 5a from the axis L. Okay. G sine theta plus, actually under the summations in this will also come, sorry. So you can take it up as a single thing. So 3m times 5a g sine theta plus, next mass is the mass of rod 2m, which is at a distance of 2a. See, this much is the distance of the rod. Center, we always take the distance d as the distance between the center of mass and the axis of rotation. So here the d is 2a. Plus mass of the particle and its distance from the axis. So mka g sine theta. Okay, here I forgot to put a g sine theta. Here also there is a g sine theta. So this becomes minus of 3 times 5, 15 mga sine theta plus, did I go wrong in the masses? Oh sorry, this is 2m and this is 3m. So this is 2m, so this becomes 10 mga sine theta plus 3 times 2, 6 mga sine theta plus mk g a sine theta. This is the formula. So I'm going to simplify this. So this is id square theta by dt square. Okay. So id square theta by dt square is equal to, simplifying this, 10 plus 6 is 16 plus k. Okay. So negative of 16 plus k, outside the bracket comes mga sine theta. Fine. Now theta is, okay, before that, theta is taken as a very small angle. Okay, is approximated as a very small angle here because theta is not mentioned. We can take theta as a very small angle and you can approximate sine theta to theta. So this becomes negative of 16 plus k mga theta. Okay. Now the next step that we need to do is id square theta by dt square is also equal to, okay, I'm writing here, id square theta by dt square is also equal to I omega square. We know that, right? So what I'm going to do is I'm going to substitute whatever I know in this. So id square theta by dt square is this thing, right? So I'm putting this here. Okay, and that is equal to what? That is equal to I omega square. So what is my I? 67 plus k square ma square, right? So I can write 67 plus k square ma square as my I, right? Times omega square. So from this I'll get omega square, right? So I'll get omega square equal to, I'm going to delete this part, okay? I'll get omega square equal to what? Omega square is equal to this thing divided by the red part, right? Black divided by red, isn't it? So I can write omega square is equal to negative of 16 plus k mga theta divided by 67 plus k square ma square. Okay, I forgot one thing. This is actually negative I d square theta by dt square equal to I omega square. So I have a negative of 16 plus k mga theta equal to this thing. So this is actually a positive term. 16 plus k mga theta divided by 67 plus k square ma square is what? That is equal to omega square. Okay. Now let us keep this aside. Okay. Now here also theta is very small. So this is approximately equal to 1. So this theta can be avoided because it is approximately equal to 1. So omega square is equal to 16 plus k mga by 67 plus k square ma square. Okay. This is what I am getting as omega square. Now there is one more formula for omega square. Omega square is also equal to 4 pi square by the time period square. So here time period is already given. So I can put t square in place of this one. So that's what I'm going to do now. So instead of this t square, I'm squaring this part. So this is 4 pi root a by g the whole square. So 4 pi square will become 16 pi square and root a by g the whole square will become a by g, right? So omega square is equal to this term. Cancelling pi square and 4 and 16, I get omega square equal to 1 by 4 g by a. Okay, a by g going to the numerator. So g by a. Understand? So now what I can do? I can equate these two things, right? Because both of them are omega square. So I'm equating both of them. 16 plus kmga, and even here I can actually cancel these m and these a's. So 16 plus kg divided by 67 plus k square a is equal to this omega square, that is 1 by 4 g by a. So a gets cancelled. And now I'm going to take this, I'm going to cross multiply, okay, so that I can solve for k. So 16 times 4, 64 plus 4k is equal to 67 plus k square. So this equation becomes k square minus 4k plus 3 equal to 0, which gives me k square minus 3k minus k plus 3 equal to 0, or k times k minus 3 minus 1 times k minus 3 equal to 0, or this is purely factorization, k minus 1 times k minus 3. So from here I am getting the value k equal to 1 or k equal to 3. So I'll just give you a brief idea once again. What we do is, in the second part, first we use the formula I d square theta by dt square equal to negative of the summation of mass multiplied by the distance of that mass from the axis of rotation. So when you take the distance, remember that you must take the center of the mass from the axis of rotation. So that's what we did first, and then we simplified that and we got I d square theta by dt square as 16 plus k mga sin theta, right? And since theta is very small, sin theta approximates to theta. Okay, so we get I d square theta by dt square as 16 plus k mga theta. Now, negative of I d square theta by dt square is also equal to I omega square. So, on substituting all the values there, negative of minus 16 plus k mga theta is equal to I omega square. I can substitute for I, which is already known in the first part, times omega square. So, from that I can get what omega square is, and that's what I have written here in the simplified form. Now omega square is also equal to using the time period formula, omega square is also equal to 4 pi square by t square. So I just substituted t square there, simplified, got like this. So I have two equations for omega square. On solving them, I'll get the k value, which is what we need in this question. Okay.